Welcome to XReality Podcast. I am the host, Dominic Wu, and beside me is the guest, Aditi. Each week, we will have conversations with industry leaders to explore the unexpected connections and opportunities between diverse sectors and the world of spatial AI and XR. Today, our guest is Greg Agriopoulos. Hi, Greg.
Agriopoulos,
Yeah. Hi, Greg. Could you share a little bit about your background with us?
Thank you, Dominic. Thank you, Aditi, and everyone. Happy to be here today and to share my story, my experience, and my background. So, I'm in the studies point of view. I'm an electrical engineer with a bachelor and master's degree, specialization in embedded systems design and wireless communications. But right after, I followed a professional career in pre-sales and sales for defense and technology projects like radar systems, surveillance systems for a Greek company that work with large enterprises in the defense like Safran, MBDA, and other groups, large groups like European and US ones, and delivered full projects, turnkey projects for the public sector. So right there, I learned a lot of stuff like financials, project management, contract management, and how to deal with large enterprises. Spent there almost 10 years, but in parallel, my key aspiration was to create a technology product because I was in the technology area during the professional and the educational career. So in parallel, I started like a hobby, a startup called Magos, and I will share more details in the coming slides and time. Yeah, thank you.
That's super exciting, Greg. I think it sounds like it's been a fun career for you. Why don't you share a bit more about Magos as well now?
Yeah, I could share a couple of slides to provide more insights for that. So let me share my screen a bit. Can you see my screen?
Yes.
All right. So Magos actually is a deep tech company. The word Magos in Greek, because I'm Greek, it means a magician. So it's about doing magic stuff in the digital world. And the motto is to enable users to touch the intangible. We have a lot of customers. You can see some high profile names in this slide. Our headquarters are in Greece. We have offices in the UK, in the US for commercialization, and we have a long story. The name and the idea came up in a European Space Agency hackathon in 2016. It was like a hobby back then, but eventually we got a lot of financial support for R&D by European Union, and then a lot of awards from innovation awards and also accelerators like the Math Challenge, Houston, and some others. And actually, let me jump a couple of slides. This is the key story. Actually, as you can see, in 16, 17, it was just an idea in a hackathon by European Space Agency. The target market was in hand and finger in sign language translation, actually, first. Eventually, we developed the technology. You can see it was TRL1, then it was technology readiness level 3, 4, etc. So besides to developing the technology, we tested the solution in different markets like 3D design, hand and finger rehabilitation, robotics, VR, AR, and XR. So everything went in parallel, let's say. So the product itself is both hardware and software, and the idea is to enable users to touch the digital world with their fingers. That's the idea.
That's so exciting. And it's cool to see that you have experimented with many different use cases and applications. And maybe why don't you tell us some things you learned over that journey? Like what was easy, what was difficult, what made you try cases?
Yeah, it's a long story, and being a founder and also a CEO and the manager of a company, you face a lot of stuff, because for a startup, initially it was 2 founders, then a few people, and right now we're almost 15 people. So one of the most difficult parts is to balance with the resources you have each period. So starting an idea, you don't need many people, and you don't know what you need exactly, because the technology is so early. So you need to mature, to identify, and to find a unique, let's say, technologist innovation, because the product is this in this area, tech innovation actually. So you need a lot of tech resources, and in the beginning you need some generalists. So the team management is very basic. In parallel, you need to acquire funding like grants or whatever, and also to make proof of concepts in markets in order to identify if this specific market is the most mature one, and the one you can address the product at. So you have 3 parts in parallel: team management, hiring people and managing them in order to get the desired result, testing the product and the prototypes, because initially you have only prototypes, understanding the customers, and in parallel find funding resources and investors to support the idea and the process.
Yeah, lots of different things to balance and juggle.
Yeah.
And
Yeah.
go ahead, Don.
Yeah. And at the beginning, right? I know, because I'm like in the process of having my startup. How do you balance, for example, like you have an idea, how do you find product market fit? Like how long did you kind of do that? And also what types of strategy that you do to found your team?
Yeah. First of all, I was not an amateur in the business sector, so this is of key importance, because I was expert in contract, project management, working with large companies, so I had a key expertise. So I will speak in this perspective, because if you're an amateur, you have much more difficulties, let's say. From this part, you need to understand, because I didn't know initially, that in the deep tech world, and especially if you develop a hardware solution, the things are much harder in testing the product. In hardware, you cannot validate the product and the solution without the hardware. It cannot happen. While in software, you can do it. You can have some mock-ups or some stuff not working precisely, and on top, being in the hardware side, where we're in the extended reality sector, which is rather new. So we had another barrier that in the local area started from Greece. Greece is not a pioneer and a leader in technology in this area. So we have to travel abroad to test the solution with large companies like Siemens, like Leonardo, and other research groups. So the most difficult part was to develop the product in a good shape, let's say, so a mature prototype, in order to test it with customers. This is the key milestone.
May I ask you how long is this circle? Because right now I am building my product. It's like a very early stage, building my app, and I am in the process of contacting my user. So how long is your cycle to understand the product market fit?
Yeah. So if you can see my slide, this slide exactly, the idea came up end of 16, start of 17. So the first customers we got and the validation was 2 years ago in 2022.
Wow, 2 years ago.
But you should point out here that we were full time from end of 20. So first 3-4 years were part-time, like a hobby. So it was 2-3 years more or less, let's say.
It's very similar to my situation, because I think at the beginning it's more like a part-time working on things. And
exactly.
Wow. So it takes probably about 3 years to get your first paid customer.
And the key part here, if you see the product from the inside, this type of product has electronics, so sensors, PCBs, etc., but also has the industrial design, the outer shape of the product, and these type of products are rather new, so you don't have any baseline. You have to develop it yourself. You have to learn from mistakes, because you will have a lot of mistakes in the story, and you will have to make decisions that will be key for the next step. So you need to be lucky to make good decisions and all this stuff, and you need to motivate the team, because this is a multidisciplinary product. You cannot do it yourself, one person, two persons. That's the problem.
Yeah. And may I ask you, how do you pick your co-founder and pick your team? What types of personality traits or skill complementary? How do you pick your team?
Yeah, initially, as you can see from the idea stage, I had one co-founder, but he left the team very soon because he looked for more academic career. So in 18, he left the team. In 18, two other persons jumped in with the prospect to be co-founders, but one of them stayed. So the most critical is from my experience, is to find people that have supplementary background and experience and personality. This is of key importance, because in these type of solutions, you have to make key decisions. So in the decisions, you don't want to have similar mindsets, similar personalities. This is key, because you need different aspects.
It's a good point. You have to make many pretty complicated decisions.
Exactly.
Yeah.
Exactly.
And I think one of the big decisions is also like what kind of use cases you go after. So I'd love to know a little bit more. I know from about 22 onwards, from what I can see on the slide, you've had connections to AR, VR kind of industry. Can you?
Yeah, I can show you a few, let's say, videos, demonstrate what we're doing, and we can discuss over that.
Yeah, that would be great.
Okay. So this is the current traction we had from 22. We had the alpha version ready, which is the first pre-commercial version. So we had commercial agreements with large and academic, let's say, customers. We tested the alpha version, received feedback, and went down for 6 months, 8 months to prepare the beta version, which was the improved version and which we are commercializing today. And this is the one that we already commercialize right now in Europe and in the US, as you can see from the left side here and the right side here, mostly focusing in medical training and simulation. The product itself, it's both hardware and software. The key innovation is that it provides sub-millimeter accuracy in the tracking part, in the finger tracking, and also has haptic feedback and kinesthetic feedback to provide the digitization of the touch sense. And of key importance, because of this unique accuracy we provide in the market, we have developed interaction libraries that allows users to apply them in order for the digital hands to interact with the space using physics or snap techniques, and I will show you right on. These are the early prototypes. You can see it was full prototypes in early TRLs, tried fabric approach, and then reached the exoskeleton type of solution here. And this is the full version. It has electronics, batteries, cabling, sensors, etc. So this is the product today. It is the software and the algorithm plays a very important role besides the hardware. So you have a digital twin of your hand. The system is an exoskeleton. That way you don't have sizes. It's one size fits all adults, and the high accuracy is very important in the solution. This is the architecture of the solution. In the hardware part, you have 2 gloves and 1 USB dongle wirelessly connected. Then we have a native application to allow users to connect and calibrate the system very fast. And then we have a mature software development kit for Unity, where software developers can develop end applications if needed for Magos and with Magos.
Super cool. It's fascinating to see some of the videos, and especially that hand digital twin was really cool. And can you tell us?
Yeah, go on.
Yeah. So you have some really exciting clients listed there. Can you paint the picture of like how do your clients use your device?
Yeah. So let's pick with some of them. We could categorize them in 2 sectors, let's say. industrial ones and then the academic ones. So let me jump in. So if you see and segment this type of customers, we have a lot of universities, but especially in the US and in North Europe, we approach mostly medical training centers, which are inside the universities that used to train surgical students and nursing students and medical students. So they usually develop either in-house end applications, or they use some software providers like the VR software company we have right here to apply VR curriculums for their students. So they perform the trainings themselves end to end for their students. So this is the most desired customer segment. We would like to enrich the capabilities of the medical training centers along with the VR software companies to use Magos and train better their staff. So this is the key aspect. As far as other groups, for example, some universities use our products for robotics, robot teaching, and I will show you right now in some more videos. But the segments are, the focus today is mostly on training and simulation for the medical groups. So
wow, that's cool. So if I understand that right, let's say there's a medical school and they want to teach their students how to perform a surgery.
Exactly. Yeah.
Like
this is a use case here. You can see a use case of this aspect actually.
I see. All right. And so that's what we're seeing is someone who has a VR headset on plus the Magus glove, and
yeah, exactly.
They're performing some kind of dental kind of procedure, like it's a.
This is intubation practice. It's called actually the patient cannot breathe and they should open the breathing area with a laryngoscope and follow a specific process.
Okay, very cool, very cool. Yeah.
And in this specific use case, there are two users simultaneously in the same scene, so they're collaborating. The one is assisting the other, of course, and this is a proof of concept.
Amazing. Yeah, I think there's so much to unpack in what you said, like it's not often that a medical student is going to be able to find someone who is going through the exact thing they need to practice. So I think this is going to be a great way for medical students to practice.
Yeah, and this use case, it's in a different customer. This is single player, actually. The previous one was the same multiplayer, and this is single player. So it's exactly the same.
Amazing.
So here you can see the yellow highlights is recordings from an expert user. So you need to guide the training during the operation. And this is for medical, but you can understand that in this specific use cases, we developed the whole project in-house, but with some other customers, we work with existing VR applications. So they would like to integrate Magos in existing processes. So this is another opportunity and capability.
Super cool.
Yeah. So may I ask you, do you think of how to integrate, for example, like an AI assistant or like an AI into this VR application, or anything AI you were thinking to integrate to your product?
Yeah. Actually, we use machine learning today for a basic our basic algorithm. So if you can see here, yeah, if you see this middle video here, it's the step of connecting and calibrating the system. So in this step, the system reads your hand size. You put your hand like full fingers stretched like that, and the system reads your hand size to adjust the virtual hand, because not all users have the same hand size. And since this is happening, we use a machine learning algorithm to read these readings and adjust actually and optimize the virtual hand. So this is the first step. In the second step, yeah, we could use AI to optimize the training, to autocorrect or auto-navigate the user during the training, which is of key importance, let's say.
Cool. Yeah. So as for the for example, when you grab stuff, as I try a couple of like a VR glove, it's pretty much using electron to do the stimulation. But for example, if I touch cat's fur and versus the water dripple on my hand. Do you have any like a kind of sensors to separate? Only just use the electron to stimulate? Because I try like a haptic X or some other PR glove, and every time when I touch something and it's all using the electron thing, and I personally think that okay, it's kind of trying to simulate, but a lot of times it's very hard to manipulate or to mimic the real world, like grabbing my phone. Actually, it's not like an electron thing, it's more like a concrete thing. How can you I don't know, like
let me explain that, because it's not an easy stuff to explain. It's more technical, but it's very critical. As I told you in this slide, actually the key innovation is in hardware. Because we provide sub-millimeter accuracy, we use some sensors that are unique, and the algorithm provides this very high accuracy, as you saw in the video. But the key innovation in the user experience is in the interaction, as you mentioned exactly, because of the high accuracy we have in the hardware, and of course in the digital twin of the hand. Then we can use some physics-based interaction techniques that enable what you mentioned, not to snap the objects and attach the objects to your fingers, but to interact with the physics like in the real world. The objects should have weight and friction, and this is what we do exactly. And this can happen only if you have this level of accuracy. If you do not, like competitors you mentioned, you cannot use the physics.
So I'm curious, for us, maybe lay people, what can you help us understand what snap-based is? And you started talking a little about physics-based, but it sounds like physics-based is where we want to be going.
Yeah. The snap-based actually is a technique where you write by code, you code down when your fingers go close to an object, a digital object, and you should describe what happens next. Because if you don't code it, your hand will pass through the object and you will have nothing after it. But the snap-based means that you describe the event that will happen if two or more fingers go close to the object. And then based on this, let's say, small scripts, the object could be attached in your fingers, be an extension of your fingers. And you don't literally grab it, but your fingers magnetize the object directly. You don't grab it literally. What I mean by physics is that this never happens, but you add the physics layer in the environment, and your fingers should balance the object between them, like it happens in the real world. And this is very unique, actually. For example, in this use case here, you can see this is a pilot training use case. In the next steps, like you will see here, we use the physics to allow the user to turn some rotating buttons that are very hard to rotate without the high accuracy. You will see the next interaction here. It's a dimmer button. Here, you should put your fingers right in the edge of the object. If you use snap, then this event will never happen. So you use physics in order to be able, with a high accuracy, to rotate it like in the real world.
Wow, that's very cool. Yeah. So it sounds like snap-based is more like a, like a singular, like a rules-based algorithm, but physics.
It's like having a button in the controller. You have a fake, let's say, interaction because you magnetize the object rather than interacting with it like in real world.
All right. Thank you so much. That's really great to learn.
I really like how accurate this is, and also you post like the snap thing. It's very interesting. I saw that. I want to try it, but it's very cool. So right now it's the shape like that looks like a spider, or it has, because I saw some Chinese company, they have a cloth on the glove.
Yeah, you mean Dexmo or which company?
Oh, I forgot. I remember I went to GDC, and it's kind of all Asian people speak Chinese, and they have kind of a glove. It's a glove. You need to wear a glove, and it's really thin. Yeah, I don't
Ah, you
know
mean
what
a
company.
fabric? You mean a
Yeah,
fabric glove?
fabric. Yeah, I'm very
Yeah.
thin. Yeah, so it's kind of.
Yeah, it was a key decision initially for us because let me go jump into the slides. I have the history of the shape of the product. We had to make this tough decision early on. We didn't have all the data between us. As you can see here, the early prototypes were semi-exoskeleton, semi-fabric. The next version was full fabric with some 3D printed external parts, and then we ended up into this full exoskeleton product. So during these first products, it was full functional, but the wearability was a nightmare. And also we needed to have different sizes of the user. And also the accuracy was not good enough because you had many sizes and the user might have smaller or bigger hands. So this was a nightmare. And we saw that with the R&D cycles internally, the exoskeleton type was the best solution because it is easy to put on, put off. The user could buy only one set for every adult, and this was a good, let's say, stability and yeah, price range of a company to buy a product.
That is such a great learning as a new startup, you know, like you can really see the iteration through rounds.
Yeah.
And yeah, I also feel that I think it's a really good point you make of uh, if you have a full fabric glove, then you have to buy multiple sizes. But if you have mostly exoskeleton, it's so much more economical and affordable for your clients.
You know, for this key decision, we had a huge advice from a mentor in an early hackathon in Mass Challenge we had. He asked us, if you go for fabric gloves, you should ask yourselves, where do people wear fabric gloves? And it is mostly for protection, actually. This is a key advice he gave us. And we asked ourselves and said, yeah, maybe he's right. And started testing the exoskeleton, and that's how it ended up.
Amazing, amazing. Like that mentor made a huge difference in your product.
Yeah, just a small discussion with a mentor made this different idea, or pushed us a little bit.
Okay, so maybe some of the questions I'd really love to hear from you about are you are building hand tracking for healthcare applications. So how do you see this hand tracking technology evolve, and how do you see this affect the future of healthcare with surgical training, rehabilitation, and so on?
Yeah, actually, the solution is a general technology solution. However, we focus today in the training and simulation mainly for healthcare, but the solution could be applied in many markets. All of the markets we have tested earlier. So the hand tracking is the hand tracking of our solution is a general solution for every sector. As far as the hand tracking, we noticed from early products in the market, because this haptic feedback market is very early for the VR. We saw that this was a key missing element from the market. Every product, the controllers were the first interaction device in the VR AR. So there was no finger tracking there. So you had just some buttons and some basic stuff. So later on, some haptic gloves came up. The hand tracking was better than the controllers, but it was bad enough. So the user experience was very blurry. You should have a clear point why not to use the controllers. And if the hand tracking and the finger tracking is not good, then you don't have this clear answer, because your product might cost 2, 3, 5, whatever €1,000 or dollars could cost. So the answer should be clear. So we saw this opportunity that we should build a device with the best finger tracking in the market, and we managed to achieve that through several, let's say, iterations. And there's a clear, unique selling point here for us. Someone could say that there is hand tracking through the cameras of the headsets or some other solutions that are wireless, but this could not be for professional reasons. The cameras could not track the hand everywhere. There is no haptic feedback, so it's clear that these solutions cannot serve a professional market. Could be just for some testing or etc.
Got it. And if you were to imagine the medical school curriculum in future, right, enabled by your product, how do you imagine that medical school curriculum, and what do you think are the changes from today?
Yeah. So I had the opportunity the last 15 months to visit a lot of medical schools, both in the US and in Europe, and I saw different approaches. Some medical schools already integrated and use VR for all of their training, so they're far ahead, for example, nursing schools or surgical schools. So for them, they're very clear. They have made a decision. They have invested in the VR technology, and our product is easy for them. It's easier to understand what our product could bring for them. So for other medical schools, they are far further from adopting VR, so they need to make an investment, find decisions, make decisions, etc. But all in all, I learned that the medical school spend a lot of money for physical stuff, let's say, consumables and mannequins, etc. in order to train students. Students do not have access all the time to the infrastructure, so they have some slots to be trained, and after that they don't train. So in many of the schools, the training is very basic, or let's say even worse. So the students could end up be trained in a real environment, and previously just train a few hours, so they're not ready. So with such a solution, VR and Magos gloves, they could fastly, let's say, learn new approaches, new techniques, and not only the students, but also experienced doctors could jump into a digital session and learn stuff like the one here. They can collaborate with experts in a remote setting, and they could learn a new process or be taught a new process in order to apply that in the real world.
Amazing. That's really cool. And I sometimes, it's also interesting to think about, medical is obviously your first big application. Have you considered if outside of medical, in addition to medical, what are some other applications?
Yeah, so I saw some videos right before, so I can share them again. This is in aerospace, actually. The training and simulation is the same. Pilot training is a huge sector, so there are many VR software companies applying and selling solutions to airlines, so to train pilots faster, easier, and as far as they would like to be trained. So this is a very good and efficient set up for a junior pilot, let's say, to be trained. So aerospace is another sector. Besides that, we have applied the solution in other sectors in the industry, like in manufacturing or in mining, as you can see here. So to train people in processes easier, in a digital world, faster, and as many times as they can. So the repetition, the efficient learning, immersion, and going deeper and deeper in the digital world, this becomes a mainstream, or from early research and development to more mainstream for the companies.
Oh, that's wonderful. Yeah, it sounds like, the common thread between some of these is if it's expensive to practice today.
No, actually, you need to compare the training from the existing, let's say, situation that happens in a physical simulator, for example, in the medical sector. The training center should buy mannequins, should equip the lab with all consumables, etc. And after the training, some other people, also some other doctors are trained in animals or whatever, so they have to clean up every time. There are specific slots, so it's not only the cost, but cost-wise, the VR and the digital training is far less expensive, I would say. For example, acquiring a laptop, a headset, and a set of gloves could not be more than $8,000-10,000 US. On the other side, equipping the lab with mannequins, and you need to replace from time to time, could cost from 20,000 up to 200,000 for a single mannequin, and you have to have different mannequins for different trainings. Also, the software development here, it's something that should be considered, but if you deploy, for example, 80, 100 use cases for nursing school, could be a very low cost compared to the annual repetitive costs of the physical lab, consumables, accessories, etc.
That's very true. So you are reducing the cost of that training quite significantly.
Yeah, and also making the training more efficient, because the user and the trainees could go train whenever they would like. The lab could provide the headset and the equipment outside the lab hours or whatever is the situation there. So there are many options to provide more efficient training.
That makes a lot of sense. Yeah.
Mhm.
And
this is another use case for augmented reality. In parallel, I'm demonstrating this video here. It's a training for real factory.
What types of training or
Sorry.
like education or training? What do you see people need this glove? But because on your website you mentioned healthcare, education, and visionary technology, or like some wearable hardware. What do you see? Because I remember on your website you also mentioned the robotic remote using your glove. I think this is a very interesting scenario. Do you have any kind of study case for example, like how can I manipulate the robot from far away? And then,
this is the next video, so you are very like good timing. So yeah, for robotics we have deployed for proof of concepts. I highlighted two here. So this first one is the latest one. We demonstrated in Siemens in Germany real-time teleoperation of a full robotic arm with fingers for flexible manufacturing. But you can understand this technology is horizontal, so could be applied in other sectors as well. So the idea is to make the robot to mimic the hand and the glove real time, and to grab and interact with objects. So as you can see, the latency is very low. It's local low, but the interaction is very good, and we made a very good approach that could be in an operational mode rather than R&D.
Wow, so it is like in this video, I can see a person who's wearing the glove and they're raising their hand, and then that robotic arm is moving at the same time.
Yeah. Actually, he used the fingers to grab the object initially, so we don't have this in the video, but the robot is mimicking the hand.
So this, I guess the application of this is that sometimes you might have like hard to reach areas, sewers, tunnels, fire. Yeah.
Actually, this is an innovation area led by giants like Siemens here. They have some activities called Factory of the Future. So they have a lot of areas where humans should teleoperate robots. So this use case is exactly useful for this area, since you can real-time teleoperate accurately a robot. This could go in many areas of the production line or emergency situation.
Wow. And tell us, like, what are some of the benefits of having that teleoperation?
Yeah. So for today, in programming a robot that is full articulated and could perform human-like actions, this is the use case here, is very hard because you have a lot of fingers, active joints, passive joints in the robot hand. So you don't have a process to easily program it. So here with this use case, we real-time teleoperate it. We don't need to program the robot to do stuff. So you can use your hand perform the action, and the robot mimics your action. So one option is to real-time teleoperate it, or on the environment, if you need the robot to interact with radioactive or whatever waste you have, and it is dangerous for the humans, you can teleoperate it real time and they perform the task. On the other side, you can teach the robot perform tasks based on glove data, and then the robot being in a situation in the real environment, you can drag the data you have in store and allow the robot to interact with the object with the data you have stored already.
Super cool, and I think possibly life-saving as well, if it can go into
Yeah.
emergency situations and so on.
And we have another demo for robotics, could be very interesting. So here, this is for inspection and maintenance. So the left side, we have the user with the headset and the glove, and the robot with the control panel. And in the left side, it's a digital twin. So we created the digital twin of the robot and the control panel. We have also 2D camera on top. And you see that the user, oops, sorry about that. The user is operating the robot to perform tasks through virtual reality. So this is an extension of the previous project using VR.
Wow. May I ask you why you need to make them to do, like, for example, like, is that possible to have a camera somewhere, the hand, so you can see the real world instead of seeing the virtual world, like creating digital twins? Like,
here is the camera. As you can see here, here's the camera with the real environment. So through VR, you see this camera output. It could be also a 3D camera and something more.
Oh, I see. Yeah. Yeah. So for example, like for this device, it can definitely prevent or like do the job in a hazard working place, such as red tag, radius, or something, or nuclear, or anything that might cause
or
hazard.
in space, yeah.
Oh,
exactly.
Or like even space, right? Because for astronaut, if I heard that if you travel to space and come back, the astronaut usually get like some cancers, or their bone, the density will lose or something. So yeah, I think this will be good to, I don't know, ISS maintenance or something. Yeah.
Yeah, and it is very important because in the glove we have haptic feedback. So if you have any sensors in the fingers of the robot, then you can sense when he touches the objects, and you can have different stuff, like feedback, real-time feedback.
Cool.
Wow, super cool.
Yeah.
I have a totally.
And this is some, go on.
No, please continue.
Yeah, here, this process is some testings we did. So we had 97% accuracy with all interactions. So this was a very, very good project for us.
What do you see the difference between like a motion capture suit and fingers? Because you are all capture the movements, and especially as far as I know, for mocap suit, because when we walk, and some sensors will kind of like for example, if my leg curls, right, and some sensors might be behind that, and same as fingers. For example, if I do finger curls. And how can like where's how can you detect the motion? So is that through the headset? There's a camera, or how can you kind of like do the accuracy through these types of challenging?
Yeah. So let me jump back to the product itself. So the product, as I mentioned previously, has some sensors. They are analog sensors not used by any competitor. So we have the sensors inside the brackets. So they're very high accuracy sensors. So they detect the motion of the exoskeleton, and then we use a unique algorithm to translate it into finger motion, actually. So this is the unique innovation. We don't have some external source, cameras or whatever, tracking the fingers. So this is why we have this level of innovation. The sensors are inside the brackets, so you don't have any external source. That's why we don't have interference or other stuff.
And so if you were to compare like, external sensors, motion capture versus your kind of sensors, like what's the advantage and maybe the level of accuracy, how help us think about that?
Yeah, actually, if you want the high level view, our product is 50 times more accurate than the closest competitor. If you want more details, let's say technical details, each sensor we use, they are able to track, let's say, round movements in two planes, so they can track 1/10 of each degree. If you move your joint or your finger 1/10 of each degree in each joint, they can track this level of accuracy. So if you combine all the sensors and also use the algorithm we have, you have this end result. But the accuracy level is many times better than any competitor. And this is why this key innovation in the hardware drive us to use the physics inside Unity to make the user experience much more advanced, which was not done by any competitor because the accuracy was not there.
Wow. And now maybe you've thought of this already, but this is also making me think about, especially with Dominique's question on motion capture, like, animated films and movies and TV shows. Could this be a way to capture that human motion? And, like, what if you put this kind of device, not just the glove, but you put like a larger device on an actor, and this is your new motion capture method, maybe. I wonder if it's still connected, or maybe we lost Greg.
Let me see. Yeah, just like echoing what you said, that this might be, oh yeah, right. This might be a great product, for example, like later on for motion capture and somebody's motion. But as far as I know, I remember a few weeks ago, we got a news, which is the stunt in Hollywood. They kind of worry about AI will replace their job because, for example, you can have some like I would say Gen AI types of video, and somehow you can make it for some very dangerous scene, right? Before we need somebody to wear a lot of protection and kind of film that shot. But because of Gen AI, if being used right, they can replace a lot of like a dangerous scene. So yeah, I love all the kind of possibilities of the glove and all the suit and everything. And I think for this glove, I think they are doing more like training, very expensive training, and which makes sense because their accuracy is like 50 times better than the competitor. So yeah,
right.
and I think they go more like high-end route. And I am amazed by the founder, like since 2016. During that time, I would say it's still very beginning, early stage for XR, and they can keep to today's kind of like achievement. I think it's amazing.
Yeah, I definitely agree. Like it's been a long journey through the different phases, and it looks like they've done so much different experimentation, right? From early prototypes to having a fabric glove to using the fabric, a lot of different experimentation.
Yeah.
Hi, Greg. Welcome back.
Apologize, but it was a network issue.
No worries, no worries. Good to have you back.
Yeah. Okay.
Yeah. I think we were having a little discussion on, can this be used in anime and kind of animated film production? But I think I am also interested in getting your thoughts about, you're the head of a very high tech new startup. You're working on a pretty visionary space. And so for you, what are some high impact goals that you are currently working towards, and how do you stay up to date and ahead of technological trends?
Yeah, that's a very interesting topic for me personally, because if you follow my background. It was my aspiration to create a technology, a solution, but also to be a pioneer in the global market. So the good stuff is that you need to read the articles to understand what is the highlights in the sector and some other sectors as well, to understand also the competition and some other areas that might be interesting for you. So you need to be up to date in a week base, in a day base, what is happening in the tech world with software, hardware, and other aspects, also sensors and technologies. So this is a very interesting topic for me. I would like to have it for the rest of my life, to follow trends, to understand what is happening, and to provide insights and to make strategic decisions based on that. But this is a key daily task for me.
And that's wonderful. Do you have like a few maybe favorite websites that you follow, or news publications? Where do you get your news?
Yeah, actually, I have many. I use LinkedIn a lot, so I follow the trends there. So this is a key social media, let's say, channel for me. But also I follow some websites like VR Day, VR News, and many others. So I don't have any preferable one. I follow the newsletter of many, let's say, websites.
Sounds great. And maybe one more question is, as an entrepreneur, what are you focused on now? Like, what are the goals? What are the next few goals for the startup?
Yeah, so the next goals, you have in parallel operation tasks and goals, and also you have research tasks and goals. So for us is to work in the research and development for the new product versions, improving the hardware, improving the algorithms, the sensors, and also reaching the software development kits, integrating with Unreal Game Engine and some other areas. The goal for us is to officially launch the new version end of this year, so in December. We expect to launch the new version and prepare a digital campaign for the company. And in parallel, expand to other sectors. I already mentioned we tested the product in design, 3D design and sculpting area, engineering as well, and also robotics. So scratching these areas and reaching a level you could provide a commercial solution is something that will be in the focus during the next year. And also manufacturing the product, providing and solving operational issues is another topic that we have week by week.
Excellent. Looks like an exciting year ahead. All the very best.
Yeah, that's true. Thanks.
Cool. So today we saw a lot of amazing technology for Greg, and I just talked to Aditi during the time when you kind of we missed the signal from you. I just feel like it's amazing that you start in 2016 when VR was still. I remember there was a moment we all think that it was the 0 year for VR long time ago, but later on, there's a hype up and down. But I really see wow, the progress. And before you mentioned that from the first time you launch to the idea to at the end you acquire your first user, it takes a couple of years, like 2 to 3 years. I think the resilience or the tenacious types of spirit, I think this is amazing. You just have to keep believing it.
Yeah, that's true. Actually, the reason is that, as you said, in 16, 17, the VR was very early, and there were some competitors earlier than that, or in their peak down there, but the market was not mature, so you couldn't sell your solution in customers because the VR market was not mature. Today is better. We have to deep dive into that and see how mature it is and to follow the trends, as you said. But I think you need to survive, you need to understand what is the support you have from investors, from customers, and proceed.
Yeah, may I ask you, like, for example, how can you get, like right now I'm also like in the process of getting like user feedback, right? So when you come up
Yeah.
with an idea, you build the product, because I want to launch a product and it might take probably like 2 months. It's not too long. Do you think that prototype need to be very finalized for your user, or it can be just catch the idea? How can, like the first time, like giving like a feedback, what do you see this types of ideation?
It depends on the product. Is it in VR sector or different sector?
VR.
Okay. So for our product, let's speak about our product first. For our product, the unique selling point is the high accuracy you have in the finger tracking, and then the user experience during the interaction. This is the unique selling point. So if you don't make the user
feel like whatever
cannot,
your selling point, you just need to show the selling point.
Yeah, or else you cannot get, let's say, any commitment or any real feedback, because the real feedback is when the user feels it and touches the product itself. So you understand that our product should be at a very good shape and robustness in order to test it. So this is very important. And we try to reach customers and try to get feedback, but the feedback was not good enough because we didn't have a mature product there. So this is the feedback I have for our story.
Cool. Yeah. So yeah, any questions, Aditi?
No, I think this is great. I've learned so much, Greg. This has been really exciting to chat with you.
Thank you, Aditi. Same for me.
Yeah, thank you so much, Greg. And let me read the thing. Yeah, thank you so much for listening. And that's it for this episode. Thank you for listening, and we release episodes weekly. If you enjoy this conversation, check out our other episodes on Spotify, Apple Podcasts, or YouTube. Support us by give us a follow or a 5-star rating, or subscribe to our channel and give us a like. Thank you, and see you next time.